Before watching the video, do subscribe my channel and hit the bell notification icon to get the instant updates.
We'll start with the next topic of organic chemistry, that's alcohols, phenols and ethers. Now the first thing, why alcohols, phenols and ethers? All the three compounds are included in the same chapter. Alcohols have a functional group as OH and the general structure is ROH. Phenols are represented with C6H5OH and ethers are represented as ROR-, the functional group as a divalent oxygen atom. So alcohols and phenols clearly have the common functional group. They are hydroxy compounds and that's the reason we are studying it together. Now alcohols and ethers have a special relation which is very important. If you look at alcohol and if I get the molecular formula, it is R with H, that means an alkane, CnH2n plus 2, and the oxygen could be separately written as O. So RH is an alkane, CnH2n plus 2O, and the oxygen. If you look at ethers, in ethers R and R' are two alkyls, and we know that coupling of two alkyl groups give you an alkane because R couples to give higher alkanes we have studied in Wurtz reaction. So R' ki jagah I can write CnH2n plus 2 followed by the oxygen functional group. Now if you observe, alcohols and ethers both have the same molecular formula but they have a different structural formula, and the difference lies in the functional group. Difference lies in the functional group. Hence, the relation what we develop over here is alcohols and ethers are functional isomers. Alcohols and ethers are functional isomers, as they have the same molecular formula but different structural formula, and the difference is in the functional group. So, alcohols and phenols have the common OH, alcohols and ethers are the functional isomers. Commonly, all the three have the oxygen in them, hence they are also referred as oxygen containing compounds. So, this chapter will be divided into three parts. First, we'll discuss about alcohols in depth, followed by phenols, and the third part would be ethers. So, let's start with alcohols. Now, the introduction to alcohol is similar to what we have already discussed in haloalkanes and haloarenes, that is the classification. The classification of halo compounds was done in two ways. One, on the basis of number of halogen atoms, and second, on the basis of hybridization of the carbon to which the functional group halogen was bonded. On the same lines, even the alcohols are classified depending on the number of OH groups. If it contains only one OH, we call it as monohydric alcohols. One OH, monohydric alcohol. So, 2 OH, dihydric alcohol, 3 would be called trihydric, and 4 or more would be called as polyhydric alcohols. 4 or more would be called polyhydric alcohols. Now, when we talk about monohydric alcohol, is similar to monohaloalkanes. So, here only I can see the second classification, that was based on the hybridization of the carbon to which the functional group X was bonded. So here OH ke basis pe I can write CsP3OH and CsP2OH. This refers to the compound in which OH is bonded to a sp3 carbon single bonded, and here it is bonded to sp2 which is double bonded. And CsP3 means it will be classified into 3, that is BAA. I'm sure you know what is BAA. That's benzylic, allylic and alkylic. Benzyl, allyl and alkyl. And CsP2OH could be classified as VA, that's vinylic and arylic. So as a mnemonic, what I say this is ba wa. So the moment I say classification depending on the hybridization, the mnemonic which strike your mind is BA-WA. That's benzyl, allyl, alkyl, vinyl and aryl. Now let's go into the details of this. Benzylic are those compounds in which the OH is bonded to a single bonded carbon and which in turn is bonded to a benzene ring. So the identification for benzylic would be benzene, a single bonded carbon and OH. Allylic means OH is bonded to a single bonded carbon which in turn is attached to a double bond carbon. Alkyl is OH bonded to a single bonded carbon which in turn is again bonded to a single bonded sp3 carbon. Benzylic, allylic and alkylic alcohols. Vinylic alcohols are those which are having the OH directly on the double bonded carbon. So if in the allyl I just skip the single bonded carbon, I get a vinyl alcohol. And here aryl के case में, if I just skip this, the OH would be directly bonded to a benzene ring. But when the OH is bonded to a benzene, it is not an alcohol. It becomes a phenol. It becomes a phenol. So while classifying alcohols, we can remember the mnemonic as BA-WA, but at the back of the mind, we should remember that aryl bonded with OH is not an alcohol, it's a phenol. Clear? Now, further to this, benzyl, allyl and alkyl were classified depending on the type of the carbon to which the OH is bonded. The moment I say type of carbon, it means primary, secondary, tertiary, meaning they will be further classified into 1 degree, 2 degree, 3 degree alcohols. And the identification from primary is CH2. Primary means CH2, secondary means CH, tertiary means C. And obviously there will be a functional group OH bonded to it. Also, for a CH2, the prefixes used are N-iso-neo, specifically alkyl alcohols के लिए. Talking with respect to this. For a secondary, we have the prefix as sec, and for the tertiary, we have the prefix as tert. So that was a detailed classification of the monohydric alcohols depending on the hybridization of the carbon to which the OH group is bonded. So this part we have discussed in haloalkanes in quite detail. Now moving to the dihydric alcohols similar to dihaloalkanes can be classified into geminal and vicinal. Geminal and vicinal. But here there is a problem. In case of geminal, the two OH groups will be bonded on the same carbon atom. But when the OH groups are on the same carbon atom, because of the H having a delta plus and O having a delta minus, there is a force of attraction between them, due to which the OH and H immediately combines to give you a water, and the moment it loses a water, what remains is C double bond O, which is a carbonyl group, and carbonyl group here can be aldehyde or a ketone, meaning geminal dihydric alcohols are unstable, meaning they are non-existent, because the OH groups are so close to each other that due to the attraction of H and O, it loses a water and forms a compound aldehyde or ketone. In fact, this forms the basis of the preparation of aldehyde and ketone, which we'll be discussing in the next chapter. So, in dihydric alcohols, by default, only the vicinal dihydric alcohols exist. And vicinal are those in which the OH groups are on the adjacent carbon atom, ajo, bajo. This is how you identify vicinal. And vicinal compounds are already given a name, common name, glycols. So, it is referred as glycol. Now, to name the compound, if I satisfy the bonds of the carbon with H, we have a rule for naming the vicinal compounds, and the rule was identify the total carbon, write the name of the alkyl and add the suffix ene. Add the suffix ene. For geminal, the suffix was idene, I-D-E-N-E. For vicinal is just ene. So with the 2 carbon, we have the name as ethyl, and adding ene, we get the name as ethylene glycol. Ethylene glycol. In IUPAC, the 2 OH groups containing compounds are called diol. So the IUPAC name would be ethane diol, with the position, of course, 1, 2, ethane 1, 2 diol. Also, in solution colligative properties, we have seen that ethylene glycol is used as an antifreeze to depress the freezing point. Ethylene glycol is used as an antifreeze to depress the freezing point, and generally it is used in automobile radiators. Moving to the next part. Trihydric alcohols also can be classified into geminal and vicinal, but like dihydric, even the trihydric geminal would be unstable, because now when 3 OH groups are on the same carbon, again the compound is highly unstable, so it will immediately lose a water. In this case, when it loses a water, what we get is C double bond O and OH, that is carboxylic acid. It means that trihydric alcohols, geminal ones, are unstable and they will immediately lose the water to give you the final product as a carboxylic acid. So again, in trihydric, we have only the vicinal ones as stable, and they will have the 3 OH groups on the adjacent carbon like this. Also, the simplest of the trihydric, vicinal trihydric alcohol is called glycerol. 3 carbon containing is called glycerol. Shortly or commercially, it is also called glycerine. Glycerol or glycerine is used in soaps and skin lotions. Also, one of the important facts, glycerol as compared to di and monohydric is highly viscous. Highly viscous, meaning the resistance to flow. The reason of high viscosity is the presence of 3 OH, and these 3 OH are present within the same molecule, so they are going to have intramolecular hydrogen bonding, because of which the molecule would be very compact and closely attracted. That's the reason glycerol is highly viscous due to intramolecular hydrogen bonding. Polyhydric alcohol mein, the most commonly known polyhydric alcohol is sorbitol. And sorbitol is a hexahydric alcohol. Hexahydric means there are 6 OH groups, obviously on the adjacent carbon atoms. So the structure of that would be COH, COH, and the middle 4 carbons would be also COH. So I have just condensed it and written COH 4 times. Now, if I satisfy the valency, this will be H2, H and H2. That's the structure of sorbitol. And obviously, sorbitol in IUPAC would be named as hexane 1, 2, 3, 4, 5, 6 hexaol. But obviously, the more common name of this compound is sorbitol. And sorbitol is most commonly used as a solvent in many of the toothpaste, food products. It's used as a solvent. So that's a summary of the classification of alcohols. Depending on number of OH, classified as mono, di, tri, poly. Mono further classified depending on hybridization into BABA. And BA further classified into primary, secondary, tertiary. So just remember this tree very well. Di and tri may remember only the vicinal ones exist, they are stable, because geminals are unstable and they immediately lose the water to give aldehyde ketone in this case and acid in the trihydric case. So, question किस तरह से आते हैं? I'll just discuss one very important example. CHCl3, that's chloroform. Now, if I treat chloroform with aqueous KOH, the Cl is going to get substituted by OH. But if I take the aqueous KOH in excess, all the Cl would be substituted by OH, and what we get is CHOH thrice. Now CHOH thrice meaning all the three OH are on the same carbon, meaning we come to the case of geminal trihydric alcohol. Now we know that it's highly unstable, immediately lose a water. So it will give you one carbon wala carboxylic acid, which is the first carboxylic acid, formic or methanoic acid. Formic or methanoic acid. So chloroform on alkaline hydrolysis gives formic acid. That can be a straightforward question asked. Chloroform on alkaline hydrolysis gives formic acid. Next, similar to chloroform, we have this compound, that's methylene dichloride. Methylene dichloride. Again, the same mechanism, aqueous KOH used in excess. Now, here we will get a product in which two OH are on the same carbon. So it's the dihydric geminal case, will immediately lose a water. And now, because of the 2H, it's going to give you an aldehyde, and one carbon aldehyde is nothing but formaldehyde. So a direct question can come, methylene dichloride on alkaline hydrolysis gives formaldehyde. Clear? Next, let's start with nomenclature. First example. Now in this we will talk about the type of alcohol, its common name and IUPAC. So looking at the alcohol, if I want to identify the type, the first thing is focus on OH, the functional group. Now you see the functional group is on single bonded carbon, that's sp3. Adjacent to that is again a single bonded carbon, which is sp3. So if this type of arrangement is there, we say it's an alkyl alcohol. Within alkyl, even benzyl, allyl, we had primary, secondary, tertiary, and the simple identification was the type of carbon. CH2 dikha matlab primary. So I will say it's a primary alkyl alcohol. Common name ke liye I had given you 3 questions. The first question to be asked, where is the functional group? It's on primary carbon. Within primary, you can have a straight chain, a T shape or plus. So if you look at the chain arrangement, it is plus, matlab it is neo. First question, you get the prefix, that is neo. Second question, how many carbons are there? 5. So it is pentyl. And what's the functional group? OH. You just add up the 3 things, you get neo pentyl alcohol. IUPAC naming, just 2 rules. Longest chain, numbering. So the longest chain is of 3 carbons and the numbering will be done from right as 1, 2 and 3. So 2 pe there are 2 substituents of methyl, we call it as 2,2-dimethyl. Parent of 3 would be propane and it will be 1-ol. 2,2-dimethyl propane, 1-ol. Next, we have a benzene ring with a carbon OH, CH3 and C2H5. Firstly, type. Simple. Type के लिए focus on OH. OH के बाजू में sp3. sp3 के बाजू में benzene. It is a benzylic alcohol. And the type is tertiary because there is C with OH. It's a tertiary benzyl alcohol. There is no common name to it. We will just name the IUPAC. In IUPAC, here the longest chain will be the open chain. You can't include the benzene ring because the OH is on the carbon of the open chain and not on the benzene. So the longest chain will be of these 4 carbons and numbering will be done such that the OH gets the least possible number, hence the numbering will be 1, 2, 3, 4. There are 2 carbons to be numbered. Now 2 pe there is a substituent. Benzene as a substituent is called phenyl. So it's 2-phenyl. 4 carbon parent is butane and the function group is, one second, it's 2-phenyl butane, 2-ol. Next, CH2 double bond CH, CH, OH, CH3. Now, the type of alcohol, once again, focus on OH. OH is on single bonded. Single bond is adjacent to double bonded. Now here, it is even adjacent to single bond. But whenever there is an arrangement and the priority to be decided, you have to follow the sequence BA-VA. Meaning benzyl has a priority higher than allyl and allyl has a priority higher than alkyl. So now we have allyl with respect to this and alkyl with respect to this. Priority wise, we have to name this as an allylic alcohol. So it's a secondary because CH hai allyl alcohol. So you observe, I have given the example of alkyl, benzyl and allyl. Okay. Now, in allylic, there is a double bond and OH together. So, two functional groups may you have to see the priority. Between double bond and OH, priority goes to OH. Hence, the numbering should be done from right. So, the parent is of 4 carbon atom, that is but. The chain contains a double bond, hence in, and OH ke liye all. Now, fill in the positions. Position is 3 in and 2 all. 3 in and 2 all. Also from 3 examples, these 3 examples, primary, tertiary, secondary, meaning the primary, secondary, tertiary, could be directly identified just based on the names. In the questions, without even writing the structure, there is a trick to identify the type of the alcohol. And the shortcut is, if the functional group is on first carbon, it is always a primary alcohol. First matlab primary. If the substituent ka position and the functional group ka position clashes, it will be a tertiary alcohol. If the position of the substituent and the functional group doesn't clash and the functional group is not on the first carbon, it will be a secondary alcohol. So this way, just from the name you can identify. See, but 3 in 2 all yani OH is on the second carbon and there is no substituent which is present over here, it is definitely a secondary alcohol, CHOH. 2-phenylbutane 2 all, 2 and 2 clashing, so it's a tertiary alcohol. 1 all, irrespective of whatever number of substituents you have, it will be a primary alcohol, that is CH2OH. That is a simple way of identifying the type of alcohol directly from the name. Let's move on to some more examples. So, I have a bond line formula given like this. I have a double bond OH, Cl, NH2, C double bond O and OH. So, whenever you have a polyfunctional compound, the first thing is identify the functional groups. So, let's see. This compound contains C double bond OH. Now, many students make a mistake of identifying this as ketone and alcohol. That's wrong. When you have C double bond O with OH, it is not ketone plus alcohol, it is a carboxylic acid. So, you have to consider this entire as a single functional group. So, we have a carboxylic acid, amine, chloro, hydroxy and alkene, 5 functional groups. So, polyfunctional compound mein, the first thing is to identify the preference, and obviously the carbon functional group gets a preference over other COH. Next, if this is the parent, the other become the substituents, and the name of the substituent for amine is amino, chlorine, chloro, OH, hydroxy, and alkene ke liye you use ene. Correct? So, the numbering of this will be done from the right, COH, and it will be 1, 2, 3, 4, 5, 6 and 7. So now in the alphabetical order, the substituents would be 2-pe, amino, 3, chloro, 4, hydroxy. Substituents over, parent is of 7, so it's hep, double bond ke liye ene, and carboxylic acid uses the suffix oic acid. And now fill in the positions. Ene is at 5th carbon, oic is at 1st carbon. But by default, the oic acid or the carboxylic acids are always going to have 1 as the position. So लिखो या नहीं लिखो फर्क नहीं पड़ता. ऐसे 3 important functional groups हैं which always have the position of the functional group as 1. It's carboxylic acid, aldehyde and cyanide. Remember it, aldehyde, carboxylic acid and cyanide all have the position of functional group always as 1 provided it is a parent functional group. Correct? It's a higher priority functional group in the given compound. Okay. Let's take one more example. Now, first question, type of alcohol. Here the OH is directly on the double bonded carbon. So, it becomes a vinylic alcohol. Becomes a vinylic alcohol. Let's say here we are being given double bond O and H. Now, double bond OH meaning this is an aldehyde functional group. So, now there are 3 functional groups, aldehyde, double bond and alcohol. Priority goes to, of course, aldehyde, and the numbering has to be done from aldehyde carbon as 1, 2, 3, 4, 5 and 6. Again, there becomes a substituent as 3 phenyl. Now, the OH is also the substituent hydroxy, so hydroxy would come first, 4 hydroxy, 3 phenyl. The parent is of 6 carbon atoms, so it is hex. Double bond is there, so ene, and aldehyde के लिए al. By default, al is at 1st position and ene is at 4th position. So it's 4 hydroxy, 3 phenyl, hex, 4 ene, 1 al. The IUPAC name. Clear?